let's now implement the is reverse of each other method. So now in this case, we have two arrays as input, IA1 and IA2. So we are not trying to return the reverse of another array. We're simply determining if IA1 is the reverse of IA2 and vice versa. Okay, and then the result is going to be a Boolean, true if it is the case and false if it is not the case. Again, you should not use any Java library classes you should only use a for loop and also primitive array structure. Okay, so now I would like you to review the background information if you still got doubts. So in the previous tutorial video, when we try to program the reverse of method over there, we talk about the insights into this reverse problem. Let me briefly go over them very quickly. So now you can think about one thing is, if you try to read the one array forwards, if it is equal to reading the other array backwards, in that case, they will be the reverse of each other. And the way to do this is by using two counters, I and j. I for going forwards and j for reading backwards. So increments for going forwards and decrements for going backwards. And also the second observation we made was to see that when we use two counters, I and j, it turns out there's a particular formula we can actually apply, which means given i's value over here, we can calculate j by using IA the length minus I minus 1. Okay, that's the conclusion we're going to use from the previous tutorial video. If you got doubts about the derivation process of this, review the previous video. Okay, so now let's see some example about how we can implement for this particular method. Let's see some example. Let's say we got IA1 over here as the first input, IA1. So that'll be the first input. Okay. Let's say the second input, there might be different cases. Let's say a very trivial case. So let's say IA2 over here is simply another array, but the size is different, the length is different. You can see IA2, the length is 4. IA1, the length is 6. In this case, even though the first 4 elements are the last 4 elements of the other array, but doesn't matter. As long as the length is not the same, there's no way you can be the reverse of that. So this one would just be false. Okay, no matter what. So now it's a very easy check for us to do. If the length of the two array IA1 and IA2 are different, then its reverse of each other should return false. Okay. Second example. Let's say if the two arrays, let's say IA1 and IA3 in this case. Okay, let me use a different color here. IA1 and IA3 over here. Let's say the sizes are the same. Now that means they have a chance to be the reverse of each other. So now in this case, we can do maybe again I'm gonna show you two versions for the solution. The first version would be, let's say we have a loop counter I starting from 0, and then we also have another counter j starting from IA.length, the length minus 1, which will be 5, and then we'll increment I in each iteration to go forwards, and we'll decrement j in each iteration to go backwards, right? That's what we'll do. So now think about it this. In the first iteration, let me just use some color to show you. In the first iteration, we'll check to see if position IA1 at position I is equal to IA3 at position j. They are equal. So far so good. Okay, so we are gonna do some conjunction to say every time when we try to see the corresponding position for I and j, the first iteration they must be equal, and the second iteration they must be equal, and all the iterations later on they should be equal as well at all the corresponding positions. So the conjunction we are doing. Okay, so it's a little bit like the all multiples of 5 problem that we were trying to solve as before. Okay, that's something you want to pay attention to. Okay, so now let's say for the second iteration, what we'll get is we'll increment I from 0 to 1 over here, and we'll decrement at the end of the first iteration, we'll increment I by 1, and then decrement j by 1. So now j is pointing to 4 over here, right? So now the corresponding elements we're considering will be IA1 at position 1 and IA3 at position 4. And they are indeed equal. Okay, so at the end of the second iteration, what we'll do is we'll again increment I further by another 1 and decrement j further by another 1. Okay, so now At the third iteration, what we will get is similar. So now we will compare 9 and 9. Okay, so far so good. Okay, let's now do one more time. Okay, we'll increment I further by 1 position, and we'll decrement j 1 further by 1 position. Okay, so now it's here. So now in the fourth iteration, what we will get is this. Okay, now what we'll get is we got IA1 at position 3 is it equal to IA3 at position 2. Is it equal? No, they are not equal. So we got the first violation witness to show us that it's not the case that all the corresponding positions are equivalents. So that means we already found a violation witness. That means they are not reverse of each other. So we have found that. So you can see that this is already shows that it's not possible. Okay, so now you can see that let's say this guy over here and this guy over here. So now you can see IA1 at position 3 and IA3 at position 2, right? So these two positions are a violation witness for us. Okay, so we know that they cannot be the reverse of each other. Okay, and then similarly, if you see another run, so you can see it is reverse of, let's say, IA1 and IA4. In this case, you can run again. You will see that that's exactly 3, 6, 9, 12, 15, 18. So that's the reverse of each other to return true. Okay, so now we know that this should return false even if they got the same length. And for this one here, they will be returning true. Let me use green for true. Okay, hopefully you get an idea. So now we're going to program the two versions directly. I'm going to show you the two versions. Again, the insights about I and j, and also using two loop counters, and also how you can see the relationship between I and j is from the previous video. You should review that if you got doubts about the logic. Okay, let me just go to the Java code and let's do it. Okay, so what I would do is I would say Boolean result is assigned to something, and then eventually I want to return the result. And then in the middle, I'm going to do something. Okay, so now for the result, remember we say that for IA1 and IA2 to be the reverse of each other, they got to be of the same length, first of all. Otherwise, we don't bother to look any further. So we can simply say, let me just show you the neatest way to do this. The result can be assigned to IA1 dot length equals IA2 dot length. Okay, that's the first step. Okay, so this step simply shows us that the result is going to first initialize as whether the two arrays are of the same length. Okay, and now what about the second step? Okay, let's say the second step let's say have the first version over here. The first version we're going to have two loop counters. So let's now declare the two loop counters. So integer I is assigned to 0, and also integer j is assigned to the last index of IA2, the length, right? IA2 array. IA2, the length, -1. Okay? You might be wondering if you should actually say if result is true, we do something, otherwise we do something else. My answer is you don't have to. That's why I want to show you how the logic will actually just work out. I'll show you. So now I can say for. So the initialization part has been done, so we leave it empty. So now we'll simply say the following. So now for the state condition over here, I'm going to make it a little bit more complicated. Usually we just say I is less than IA1 dot length, and then we will also get the I plus plus over here, and then also j minus minus as we did before in the previous method. Okay, so now over here I want to say a little bit like this. We know that result has been already initialized to the following result to say if the size of the two arrays are equal. If they are not, that means result is actually false. In which case, we should not even bother to execute this loop over here. So that means that we should somehow make the state condition false in this case. What can we do? We can simply say result and like this. Okay, so now let me document it for you. In case result was initialized to be false, meaning that IA1 and IA2 are of different lengths, right? From this line over here, right? If IA1, IA2, they are of different length, in which case it would just be false in this case. Okay, meaning that, okay, and then the very first evaluation of the state condition over here, which will be a conjunction over here. State condition, which is a conjunction, will be false. In which case we bypassing the body of the loop. And then once we bypass, we just return result being false. Okay, so that works out if the size is not equal to each other. Okay, so now how do we do that over here? So now we want to say, so over here you got two choices. You can either say result in case they're of the same length. In case in this line over here we set the result to be true. That means IA1 the length is equal to IA2 the length. In that case, true and maybe and something depends on just over here, this expression over here. Let's say if we could really go into the loop, what should we do? Okay, you got two options over here, both work. You can either say result is assigned to accumulated with result, and also we want to see if the current elements, if the current corresponding positions of IA1 and IA2, right? We have I and J over here are actually equal to each other, right? I show you the different green to green, blue to blue, orange to orange. Okay, so now over here I can say IA1 at position I equals IA2 at position J. Okay, this is one way to do it. Okay, this one works perfectly. However, if you try over here, since now we talk about version 1, right? Okay, so now this is version 1. Version 1 using 2 loop counters. So now let me just call this version 1.1. 1.1, which means accumulates result using conjunction. Okay, let me show you version 1.2. Given that result is part of the state condition, which is a conjunction, it's guaranteed that as soon as result is reassigned to false, the state condition becomes false. Okay, it's very important. So what I mean is I can simply just get rid of this and I'll just leave that one here. Okay, version number 2, I will simply put result. Okay, version number 1, let me just comment it out. It works. Okay, without any trouble. So now for version number 2, I can say result is simply assigned to IA1 at position I equals IA2 at position J. Okay, sorry, accidentally launched this. Okay, so now let's put a semicolon over here. So this one also works. Think about why it works. So now as soon as we get to this particular position over here, you can see I being 3 and J being 2. 12 is not equal to 13, right? In that case, this expression here is going to give you false. So result will be assigned to false. And then when we go, when we reach the end of this iteration over here, we have to evaluate the state condition again. In that case, result being false is going to cause the whole state condition to be false, because as long as one side of the conjunction is false, the whole conjunction is going to be false. And then we exit from the loop. And then, that's why this will also work. So it's guaranteed as soon as, if we try this one over here, as soon as the result becomes false because of the first violation witness we find, then it's going to exit from loop and then return result being false. Okay. Okay, that's about version number 1. Let's briefly test it. Okay, so now we got utility tester over here. So we want to see is reverse off. Okay, is reverse off over here. So we got the different operations over here. Let's just check a few. Okay, you can also check the rest. If I just run the code, run the tester over here, let's see a few. Okay, first of all, we have IA2 and IA3. Okay, you can see IA2 and IA3. They are not the reverse of each other, right? You can IA2 and IA3 is reverse of each other, so false. Okay, you can see the first one is correct. Okay, so now what about the second one? IA4 and IA5. IA4 and IA5. Apparently, they are not reverse of each other. Okay, so now it's also false. Okay, and also we have the next one. So the next one is we have is IA4 the reverse of itself. So now in general, an array is not necessarily the reverse of itself. Okay, I will give you some example over here. You can see that IA4 over here, the easy way to test, if you read IA4 forwards 5, 10, 15, 20, 25, if you read it backwards, it's not the same. It will be 25, 20, 15, 10, and 5. It's not the same. Okay, but what can be an array that is the reverse of itself? I'll give you one example. For this array over here, you can try that later. 5, 10, 15, 10, and then 5. Okay, in this case, this array over here, the array is the reverse of itself. If you read it forwards, 5, 10, 15, 10, 5. Backwards, 5, 10, 15, 10, 5. Okay, it's the same. But now in this case, of specific value for IA4 is not the reverse of itself. So now we expect to see the result being false. So that's why you see the false over here. Okay, next one. The next one will be, we got IA1 is in the reverse of itself. IA1, over here you can see IA1 is a special case, just empty array. Empty array, read it forwards, nothing. Read it backwards, nothing. Nothing is equal to nothing. So that's why it's, so that should be true over here. Okay, next one. Okay, when we see the next one over here, the next one finally will be IA4 is not the reverse of itself. So now we are trying to do something a little bit interesting over here. IA4 itself, and now we simply call our previously implemented method reverse of. So what's going to be u.reverse of IA4? U.reverse of IA4, as we learned from before, is going to return 25, 20, 15, 10, and 5. So now that array is indeed the reverse of IA4, given that our reverse of method was correct, right? Okay, so hopefully you can also understand this particular test case over there for the reverse of each other. Okay, so over here. Okay. Now let's now go to the second version, given that the first version is working. Okay, that's the first version over here using 2 loop counters. Now let's do the second version over there, which will be based on our observation from the previous video that we have this formula over here for us to make use of, which is j is equal to ia.length minus I minus 1. Okay, that's something we can make use of. Okay, so now let me just comment the first version out. Okay, that one definitely works. But now what I will do is I'll comment this out, and then I'll give you the second version. Okay, version 2 using 1 loop counter. Okay, now how do I do that? So now I can simply use put a loop counter over here. Integer I is assigned to 0. I is less than ia1 dot length, and then I plus plus. And then, so now I can see, again, I still got 2 versions over here. Okay, I'll show you both, okay? Version 1.2.1. Again, let me just accumulate the result using conjunction. Okay, let me just be a little bit lazy here. I can just copy and paste over here. So what I can say is, I can say result is assigned to result accumulated using conjunction with ia1 at position I equals ia2. Used to be j in the first version, but now j can be derived using ia1 dot length minus I minus 1. Okay, that's what we have. Okay, that's version number 1. What about version number 2? Again, let's now, let me just, again, be a little bit lazy here. Let me just copy this comment over here, because we also got a version for 2.2. Okay, let me just move this over. So now version 2.2. Okay, given that's the state condition over here, so now I forgot to actually put the result over here. Okay, it's really important to put a result because you want to make sure you enter this loop over here. Okay, it's very important. It's important to put result as part of the state condition because we want to be sure that we execute the body of loop when the two arrays IA1 and IA2 are of same length. And remember, in the first line we said result is assigned to the length being equal. So that means if we include result as part of the state condition, we only enter the loop when they are of the same length. Okay. So now let's now do the second version. The second version over here will simply just basically, let me just copy this, and then I'll just get rid of the accumulative part. Okay, just that, because I know that as soon as we reach, for example, again over here, as soon as we reach, for example, this case over here, where I is 3, and then IA1, the length minus I minus 1 will just be 2, which is how we called J before. And then the values are not equal. As soon as this is the case, which will make the result over here, which will make this expression over here false. And it's going to make the result to be reassigned to false. And then it's going to make this re-evaluation of the state condition false. So we exit from the loop and return false. Okay. So now we just keep version 2.2 for you. Okay. So both, you can see we got 1.1, 1.2, 2.1, and 2.2. All of them work. Okay. Let's now just have a quick look on the tester. And then make sure it works before we finish this, conclude this video. Okay, so now let's now execute the tester over here. So now here we got false, 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 true, true. Okay, so now what we will get is reverse of each other. Okay, we still get the same, exactly the same result: false, 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 true, and true. Okay, you can just double check your. You should really double check to see that all the 4 versions that I gave to you, they all work the same way. Okay, externally, which means all the test cases still pass. Okay, 1.1, 1.2, 2.1, and 2.2. Again, this is really based on the observation we made from the previous video between the loop counter I and J. Okay, these 2 loop counters. Okay, if you still got doubts, you should review the previous video before you do this one.